You've entered a two-part training. Each part contains a new challenge. Complete them both to prove your mastery and earn the Order of Operations badge. 2 students evaluated this expression. 6 plus 4 times 2. Student A got 20. Student B got 14. Which student evaluated the expression correctly using the order of operations? Why is it important to follow the order of operations when evaluating expressions? How else could the multiplication in this expression be shown? Study well. The path to mastery begins now.
Welcome back, Math Masters. I have a feeling we'll need our knowledge of simplifying expressions to conquer today's challenge. Have your guided notes ready. Training starts now. Today, we're going to explore different ways we can show multiplication. We've been working with the multiplication symbol that looks like an X, but there are other ways to show multiplication too, especially when we're working with variables. Sometimes the letter X is used as a variable, so it could be confusing to show 6 times X with a regular multiplication symbol. That's why there are different ways to record multiplication. We can use a dot, like this. Or we can use parentheses, like this. Finally, we can record a digit right next to a variable, like this. With the first 2 representations, we can use digits or variables, but the last one can only be used if one of the values is a variable. Now, let's try solving a few multiplication expressions using these different notations. Substitute the value of the variable into each expression, then evaluate. Pause the video here to record your thinking. After substituting the value of C into each expression, we can simplify. 12 times 3 equals 36. 3 times 9 equals 27. 8 times 3 is 24. And 15 times 3 equals 45. Nice job! We've evaluated multi-step expressions before, but how do we know if we've simplified correctly? Not every expression can be simplified by working from left to right all the way through. We have to use the order of operations. It's a sequence in which mathematical operations should be performed. Without the order of operations, the same expression could be simplified in different ways and lead to different answers. Using a standard order ensures that everyone evaluates expressions the same way, which keeps math consistent and reliable. First, we simplify anything inside grouping symbols, like parentheses. They tell us to focus on one part of the expression first and simplify it before doing anything else. Next are exponents, because they're a faster way to do repeated multiplication, but we won't be working with them with the order of operations in this course. Then comes multiplication and division. These 2 come next because multiplication is a way to do repeated addition, and division is a way to do repeated subtraction. Since these are inverse operations, they're on the same level. That means if both show up in an expression, we don't always do multiplication first. We simplify them in the order they appear, from left to right. And finally, we do subtraction and addition. They're the most basic operations, so they come last in the order. They're also inverse operations, so they share the same level. That means we don't always do subtraction before addition. We simplify whichever comes first as we move left to right. You're right, Mia. The first letter in each step in the order of operations spells gems. That's a helpful training tip to remember the order. G for grouping, E for exponents, M for multiplication and division, and S for subtraction and addition. Let's try using the order of operations with this expression. What will we start with? There aren't any grouping symbols or exponents, so we'll start with multiplication or division. Simplify 9 divided by 3, which equals 3. Remember to bring down the rest of the expression. Pause here to finish evaluating the rest of the expression. What did you do next? Since there was still multiplication, we needed to multiply 4 times 2. Then, there's only addition and subtraction remaining. Since they're on the same level, we simplify from left to right. 15 plus 3 equals 18, and 18 minus 8 equals 10. Nice job! Your challenge still awaits. Complete it to finish the first part of your training and get one step closer to earning the Order of Operations badge. 2 students evaluated this expression. 6 plus 4 times 2. Student A got 20. Student B got 14. Which student evaluated the expression correctly using the order of operations? Why is it important to follow the order of operations when evaluating expressions? How else could the multiplication in this expression be shown? Pause now to solve the challenge. Student B evaluated the expression correctly. According to the order of operations, multiplication comes before addition. So we simplify 4 times 2 first, which equals 8, then add 6 for a total of 14. Student A didn't follow the order of operations, so they added 6 plus 4 first, and then multiplied. Following the order of operations is important because it gives everyone the same steps to follow. Without it, people could evaluate the same expression in different ways, like these students did, and get different answers. Instead of writing 4 times 2 with the regular multiplication symbol, we could also show the multiplication with a dot or parentheses. All 3 notations mean the same thing. So, what have we learned today? We learned that there are different ways to show multiplication, and they all mean the same thing. We also learned that following the order of operations helps everyone evaluate expressions the same way and get the correct answer. Your training is off to a strong start, but the lesson is not yet complete. Be sure to complete the practice questions that go with this lesson to practice evaluating expressions using the order of operations. Return for part 2 to face your next challenge. And remember, Math Masters, in math, as in training, progress comes with patience and practice.